Welcome to the DIY Honda Garage channel. This presentation focuses on the DTC P011B, which indicates an intake air temperature (IAT) sensor circuit range performance problem in the Honda Accord models from 2012 to 2017. The Powertrain Control Module (PCM) utilizes two engine coolant temperature (ECT) sensors and one IAT sensor to regulate engine performance. When the engine is off for a sufficient time, the temperatures of ECT and IAT sensors will normalize to ambient conditions. If there is a significant discrepancy in readings, the PCM will flag this as a malfunction, leading to the storage of a diagnostic trouble code, DTC. The DTC P011B specifically arises when there are inconsistencies between the readings of these sensors during diagnostic checks. Therefore, understanding this error code and the sensors involved is crucial for maintaining optimal engine performance and reliability. The DTC P011B pertains to issues identified with the intake air temperature (IAT) sensor, which is crucial for the engine management system's performance. The IAT sensor measures the temperature of the intake air, which directly influences fuel mixture calculations and ignition timing controls by the PCM. The sensor is typically located near the air intake manifold, ensuring it accurately captures the air temperature that the engine will utilize for combustion. Its readings are compared against those from the two ECT sensors. A malfunction will lead the PCM to detect a range or performance problem, signaling that it is unable to effectively assess the engine's temperature conditions, which can ultimately affect vehicle performance and efficiency. Several potential causes can trigger the DTC P011B code. Firstly, a failure in ECT sensor 1 could disrupt normal readings, leading to incorrect temperature assessments. Similarly, an issue with ECT sensor 2 may also cause discrepancies in temperature readings between the sensors, triggering the code. Additionally, a malfunction in the IAT sensor itself is a primary suspect for generating this fault. Furthermore, if a non-genuine engine block heater is used, it could influence the readings due to inconsistent cooling during engine shutdown. It is advisable to investigate these components sequentially to identify the primary source of the issue in the sensor circuitry. The symptoms associated with DTC P011B can significantly affect vehicle performance. Primarily, drivers may notice engine performance issues, such as rough idling or poor acceleration, as the PCM adjusts fuel and timing calculations based on inaccurate sensor data. The malfunction indicator lamp, MIL, will also be illuminated, warning the driver of an underlying issue that requires attention. Additionally, drivers may experience reduced fuel efficiency due to improper air-fuel mixtures being fed into the combustion chambers, which may ultimately lead to increased emissions. Recognizing these symptoms early can aid in diagnosing the problem promptly and mitigating further damage to the vehicle. The initial troubleshooting step for DTC P011B requires you to turn the ignition switch to the lock position or press the engine start-stop button to select the off mode. Once this is done, it is essential to wait at least 6 hours before proceeding. This waiting period allows the engine temperatures to stabilize to ambient temperatures, making sensor readings more accurate for diagnostic purposes. After the wait, start the engine and let it idle for a minimum of 10 seconds to allow the PCM to gather new data from the sensors. Avoid using an engine block heater during this process, as it could lead to uneven temperature readings at the time of diagnosis, rendering the results inaccurate. Following the initial step, it is crucial to assess the ambient temperature when evaluating DTC P011B. The reading should ideally be close to the intake air temperature documented in the freeze data to ensure proper conditions for testing. If there are significant discrepancies in the ambient temperatures, it might interfere with the accuracy of the malfunction judgment process. Additionally, when testing, avoid moving the vehicle between environments with extreme temperature changes, as this could affect the conditions under which the sensors operate. For instance, if a vehicle is parked in a heated garage, you must open the garage doors to introduce outside air before starting the engine. These conditions are essential for accurate diagnostics of the IAT and ECT sensors. After completing repairs related to DTC P011B, it is important to conduct a final verification process to confirm that the issue has been resolved. Begin by ensuring that all components involved in the diagnostics, particularly the IAT and ECT sensors, are functioning correctly. Following that, use a scan tool to clear the DTC, which resets the PCM's memory regarding the detected error. The final step involves a test drive of the vehicle. Monitoring the MIL status during regular driving conditions serves to determine if the fault reoccurs. If the MIL does not illuminate during subsequent cycles, it confirms successful resolution of the issue. To prevent the recurrence of DTC P011B, it is essential to implement a regular preventive maintenance routine, focusing on the vehicle's temperature sensors. Regular checks of the IAT and ECT sensors can help identify possible issues before they escalate into more significant problems. It's equally vital to use genuine Honda parts for replacements to ensure compatibility and reliability in the vehicle's performance. By monitoring engine temperatures during routine checks or through diagnostic scans, any deviations from normal parameters can be caught early. This proactive approach not only extends the lifespan of the sensors, but also contributes to overall vehicular efficiency and performance. In summary, DTC P011B highlights the critical role of the intake air temperature sensor in the vehicle's engine management system. Understanding how this system functions and the significance of accurate readings is paramount for maintaining engine performance. Regular monitoring through Onboard Diagnostics 2 (OBD-II) tools can aid in early detection of such issues, ensuring timely interventions. Moreover, by conducting routine checks and adhering to preventive maintenance practices, drivers can avoid potential malfunctions that may affect vehicle performance and fuel efficiency. Timely repairs are essential to sustaining optimal engine conditions and extending the vehicle's lifespan, ultimately delivering a smoother driving experience. Please like and subscribe to the channel. See you next time!